Welcome to my channel, everybody, viewers. And this is one of the important problem for gamma function. Okay, see, this is rho within the bracket m coin, where the limit is there 0 to 1, and integral nth root over ln within the first bracket 1 by x to the power m, and again divided by over root over n ln within the first bracket 1 by x to the power n over nth root of daughter to infinity. So see this pattern. Let us assume this whole formation as a p. So p is equal to nth root of ln 1 over x to the power m and whole divided. These are repeat same pattern. So p, if we let whole thing is a p, so p are repeat. So we substitute here as a p. So this is the nth root. So p to the power n is equal to ln 1 over x to the power m by as a p. So implies that p to the power n plus 1 is equal to minus m. So m to the power x to the power minus m. For the general log, the power is there, m are came to the font size in the font, okay, minus m into ln x here, okay. So then p is equal to, again we can write here p is equal to, so m to the power 1 by n plus 1 and minus ln x to the power 1 by n plus 1 here, okay. Now if we substitute here as a 0 to 1, and this is here as a, this is let us assume as a p. P means is this. So m to the power 1 by n plus 1 and minus ln x to the power 1 by n plus 1 and dx here. So now this is the constant. So m to the power 1 by n plus 1, and let us assume 0 to, limit here is 0 to 1, so minus ln x to the power 1 by n plus 1 and dx, and let us assume this as a z. So let z is equal to minus ln x. So differentiate dz is equal to minus 1 by x and dx here, okay, dx here. So now x, here x means e to the power minus z, and substitute here, so you can write like now dx is equal to minus x, this is e to the power minus z and dz here, okay, and substitute the variable here, m to the power n plus 1 is a constant here. If we substitute this variable z, as see the limit here is x is 0. If we put here, then log 0 is infinity, and same as if you put here 1, so log 1 is 0. So this is the limit, and now this variable as a z, so z to the power 1 by here n plus 1, and since dx is equal to minus e to the power minus z and dz here, see there is a minus, so limit is here a to b, so we can write here between. So that's why m to the power 1 by, that is here n plus 1, and we can write here 0 to infinity. Lower is 0, upper is infinity here. And now z to the power 1 by n plus 1 and e to the power minus z and dz here. And from the gamma function, and we can write like this 0 to infinity e to the power minus x and x to the power n minus 1, and that is equal to gamma n, since, okay. So the formation is came out here m to the power 1 by n plus 1, so again 0 to infinity, and that is z to the power, we can write 1 by n plus 1, and this is plus 1, then subtract 1 for formation of the gamma function, there is a minus 1, so that's why we can write like now, okay, e to the minus n at dz, Again rewrite here m to the power 1 by n plus 1 and c 0 to infinity and z to the power n plus 2 by n plus 1 and minus 1 e to the power minus z and dz. Okay, then n to the power 1 by n plus 1 and this is gamma n plus 2 by n plus 1. This is the answer. Okay, I think all of you have better understood for this problem, and in my point of view this is an interesting problem. See carefully. Okay, right.